we're off and running with Mr. Neff here, and today I want to talk to you about I can graph linear inequalities. So this is lesson 6.5 in our current book. I hope to use these videos maybe for a long time, so it may change if I get new books. But here we go. Inequality, really, we understand an inequality is anything that is not equal to. It's not an equation, so you're going to have different symbols, less than. And here's what I remember, less than points left. You got less than or equal to. So less than points left, and then greater than's the other one. So I just remember that, or what's the trick? Well, there is no trick because, as I just said, less than points left, so the other one will be greater than. And then, of course, the other one you'll see that is considered an inequality symbol is that just means not equal to. Okay, and so we're off. All right, first one, are these solutions to this? So we're saying y is less than x plus 2. And are these, in each of these situations, are they solution? So, and there's an infinite number of solutions here. So I'm going to look here, -5, if that's x, and then y is 2. Is that a true statement? So I'm going to insert in 2. Is that less than -5 plus 2? So the value here, 2, is that less than -3? Okay, no, that is not true. So that's not going to be true there. The next one then, all right, let's look there. And is 6 less than 4 plus 2? Well, now you have 6 less than 6. No, that's a false statement. So no, that is not true. If there was a line under it, yeah, that would be true. But since there's not, then that's a false statement there. Okay, keep moving here. I'll erase that workspace one more time. And go to green here maybe. Is 0 less than 6 plus 2? 0 is less than 8, and yes, that is a true statement there. So that's one of the solutions to that. Now what I think I want to do really in this next example here is just graph that one to show where the solution space lies for that. And so we create a boundary line for that when we graph. So we're going to create a boundary line for the line y equals x plus 2. That's our boundary line. All right, and it's going to be a dotted line because there's no line under it. So first create the boundary line by putting a dot at the y-intercept of 2, and then you rise 1, run 1. So don't worry about the sign other than the line. Okay, and we can go the other way, down 1, left 1. And then now, there's my line. Oop, good thing I have undo. Dotted line. I'll try, dotted line, that's a little tricky. Okay, and then it says less than. Now this can be a little tricky, but less than is usually the line below it. So I'm going to shade, get out my, I'll shade in purple, sure. Right here is where I believe my solution area is. And what I'm going to do is pick another test point. Actually, I already have a test point if I go back here. 6, 0 is my test point to prove it right here. But I'm going to usually pick a test point like 0, 0 to see if it's true. Okay, so is 0 less than 0 plus 2? Is that a true statement? So that's my test point right here. That's a true statement. That tells me, 2. 0 plus 2 is 2, right? That tells me that that is true, and I shaded the correct way. If I pick anything in the other area, guess what? It'll be a false statement, as we already saw before, that would show us there's not a solution to that. Okay, so that's one to look at here. Let's just look at one more to practice here. Graph y is greater than x minus 1. So forget the sign for a second, and we're going to graph y equals x minus 1 to get our boundary line. And again, it's going to be dotted. It's easier to do a dotted line for me right now anyway. It'd be solid if a line was underneath it. So put a dot at -1, very similar as before. We're rising, okay, and we're running all the way down just like we did with the slope of 1 again. Same slope. Rise and run. And then there's my dotted line. And this time, I believe it looks, the area kind of above the line, which can be confusing, is this area up here. All right. Now 0, 0, I'm going to use as my test point because it looks like that's in this shaded area. Even if it's not, you could use 0, 0 as a test point. And if it doesn't work, you know you're shading the other way. So 0, 0 could always be your test point if you wanted it to be your test point. Okay, but yeah, let's use 0. Is that greater than 0 minus 1? 0 is greater than negative 1. That's true, we shaded the right way. Again, if I picked like 10, 0, we would see that that would be a false statement. And maybe let me just show you that really quick here. Okay, if I pick 10, 0, well, 10, 0 I said, right? Okay, is 0 greater than 10 minus 1? No, 0 is not greater than 9. That's why I'm not shading over on this right side, just on the left side up here. That's my solution area, and that's graphed. And then the hardest, easiest thing in the world are these right here. So x is less than 2. Well, you're going to graph x equals 2, and that's going to be a vertical line. A dotted vertical line. It's a little tricky to do this on here, but you get the idea. You can do it better with pencil and paper than I can do there. And this says less than, and this should be a real no-brainer here. You're going to shade everything over here. Okay? All right. And that would be where I would shade everything less than 2. Okay? Let me actually duplicate that. Okay, let me do now y is greater than or equal to negative 3. So you're going to use the line y equals negative 3. That's a what type of line? Horizontal. Great. So I'm going to create a horizontal line at y equals negative 3. And this says everything above that line. So I am now going to shade right here. And that's my solution area here, above that line, right? Anything below negative 3 is not going to be a solution. Like negative 4, is that going to work? Negative 5, is that going to work? Nope. Negative 6, and there's the bell. I recorded this perfectly in time, and that ends Learning with Mr. Neff. Now time to explain this to the class. Hopefully they understand it.